And our first panel of the day, really taking a much deeper dive into the technology and the innovations that can make a difference in the lives of rare disease patients. We're pleased to welcome Dr. Bradford Wilson. He's the co-founder and chief scientific officer of Indigenous AI. It's a genomics company leveraging data and artificial intelligence to speed up the drug development process, while also addressing health disparities, especially among the minority community. And Dr. Ann Pariser is the Vice President and Medical and Regulatory Affairs at Alltrna. It's a biotech startup working to develop tRNA as a therapy that could be used in thousands of genetic diseases. Prior to this, Dr. Pariser was the director of the Office of Rare Diseases Research at the National Center for Advancing Translational Sciences. And so to both of you, thank you. Dr. Wilson, I want to begin with you in particular with the population that you were doing the most research among African Americans. But I want you to explain, if you could, what is genome sequencing and what do you hope to learn?
Absolutely. First and foremost, it's a pleasure. Thank you very much for the invitation to be a part of this discussion. What genome sequencing is essentially taking your genetic material or your DNA and determining the precise sequence of the letters in the genetic code of your complete genetic code. And that to this date has been quite expensive, but recently the cost has been reduced drastically, which then creates the opportunity for large-scale sequencing and whole genome sequencing, meaning sequencing of the entire genome, all 3 billion letters of your genetic code. And this is essentially, this is unique to everyone, and it provides an unprecedented level of information about that individual on a molecular level, as the genome provides the instructions to code for all of your body's proteins, essentially. And it serves as your body's blueprint for construction of its proteins. And what we now know, as over the past 20 years, as we've completed the draft of the genome about 20 years ago, is that we have the ability to identify specific variants that correlate directly with given disease phenotypes. And in the rare disease population, or when we're looking at rare diseases, this is a very, very powerful tool that can be leveraged to quickly identify the causal factors in terms of genetics, and also identify biomarkers that can then lead to early diagnosis and ultimately for improved outcomes.
So let me follow up on that point. Clearly, if you are the patient, you want to find out the causes and potential cures. If it's a loved one that is suffering from a rare disease, what will this tell that individual?
For relatives of individuals with rare diseases, the family unit, a family cohort, is a very powerful, is an even more powerful tool, as you have individuals who are genetically related, share genetic sequences and share a DNA sequence, a certain percentage depending upon the level of relationship. But then you have individuals within that family, some of which are affected and some of which are not. So within that family, you can compare members of that family and then quickly identify the genetic variants or the genetic drivers of that rare disease.
And Dr. Pariser, you are on the front lines of trying to find treatments and cures for these individuals. We've been talking about the problem. Where are you optimistic? What are the silver linings in all of this as we move forward?
Oh, I think there's a lot to be very optimistic about right now. We've had tremendous advances in our our ability to analyze the genome sequencing for individuals and as well as the groups, and also for disease specifically to find whatever that molecular underpinning is. And once you find that underpinning, well, that now gives you a target that you can go after. And this is really where the vast majority of drug development is now, is these precision approaches where you know what that underpinning is, and now you can design drug therapies around that. So, for example, we're seeing a big increase in genomic therapies, where, for example, you're lacking a gene and now you have the ability to give it back. Or what's coming on the horizon is editing. So what is that specific mutation? Can we go in and just change that specific mutation? Or can we alter the reading, the mRNA or the reading frame, and how it translates into a protein? So these are all things that are just undergoing a lot of development right now, and a lot of these have the potential to just be incredibly effective.
But as you know, so often it's not just a single rare disease. Often it's rare diseases that a person is suffering from. So how do you combat that with treatment? Because it seems to me, from a layman's term, it can get pretty complex.
So for the most part, when you're looking at some of these very serious rare diseases, a lot of them are what we call single gene disorders, where it could just be the change in just one amino acid in one gene that can cause a whole host of problems. So I think we have to keep in mind that the diagnosis has improved drastically in recent years. So most people we're seeing now do tend to have one disease. That's not to say there aren't a few people that don't have more than one, but that's where a lot of the illness that we're seeing is. And that now we have the ability to focus very hard in on those individual disorders.
I want to spend a moment to focus on the organizations that you both represent. And Dr. Wilson, you're the co-founder of Indigenous AI. So explain, first of all, the name and your mission.
Yes, the Indigenous, it's pronounced Indigenous, but there's a focus on genetics, and hence the unique spelling. And our work in our company is focused on, genetic, health disparities that disproportionately impact traditionally underserved and underrepresented populations. And this is our mission, because we know that essentially the field in terms of genetics is very, very skewed in terms of the data that's been generated, and where less than 3% of all the genetic data from large-scale studies like genome-wide association studies or GWAS studies represents populations from the African diaspora. And the significance of this is that those populations just so happen to be the most genetically diverse. And if they are not represented in genetic studies, often is the case is that there are population-specific variants, population-specific mutations that are driving diseases in these populations, and that can potentially account for some of the disparities that we see in many of these areas.
And Dr. Pariser, the work that you do at Alltrna, and I'm curious the cost and benefit of the research, the treatment, and the number of people you're able to offer those services to, while also be able to continue the research, which costs a lot of money.
It does, but I think we also need to keep in mind that these are overwhelmingly serious diseases, and serious diseases, it costs money to take care of people who are ill. But if we can focus on trying to make a difference in that disease trajectory, then we're really working towards trying to put those costs towards improving people's lives, rather than merely managing the relentless progression of these disorders. So, I think that's true of all diseases, rare and common. If we can manage these diseases, attenuate them, even cure some of them, then, it's money well spent towards improving people's lives.
And we talked about this with Congressman Davis, but from your perspective, Dr. Pariser, how do you speed up the process, and where are the roadblocks when it comes to some of the treatment?
I think some of them people have already mentioned. We certainly need much better access to whole genome sequencing. And it's not just that people get access to it, but we need timely access to it. A lot of these diseases are chronic and relentlessly progressive, and we want to get to people before they have irreversible complications. So we should be getting these sequences early while we have a real chance to intervene. And some of the efforts Dr. Wilson is doing using machine learning, using medical records, developing algorithms to try to find people who are undiagnosed in systems using information that we already have. These are some really promising techniques. And, nobody can walk around with 10,000 different diseases in their head. We need the machines to really help us. And then also you can't diagnose people unless you think of these. And rare diseases, I think, as you very well said, rare diseases are not rare. Collectively, they're not rare. And frontline physicians are going to be seeing these. And we need to really raise the awareness, if not for a specific disease, but that a rare disease is a possibility, and try to escalate those people much faster with appropriate testing.
And Dr. Wilson, you talked about the minority population, which is often underserved, and clearly inclusion is a key part of the work that you're trying to do. But there are so many other factors that come into play, economic and social factors, in trying to make sure that you are reaching the patients, and more importantly, that the patients are reaching you.
Absolutely. There, unfortunately, there is a trust issue with members of these populations. And as a result of, some historic, unfortunate events and some historic exploitation, for example, the case of Henrietta Lacks. And as a result, there is a need for an increased level of transparency in order to establish that trust of these populations for them to participate. And but the significant point is that their participation is critical and it's essential, right? And it's not only critical for identifying drivers of health disparities, but also identifying signatures and patterns of variation that are associated with health. And that stands to not only benefit these populations, but all populations.
And Dr. Pariser, I'm curious, is there a sense of urgency among researchers as we move forward on all of these fronts?
Yes, there absolutely is. I really think in the past, 5 to 10 years, it's a very different environment now with the better understanding of genetics and our ability to really go after these diseases in meaningful ways. And every day, really, we have more examples of successes and advances that our ability to make a difference now it's here. It's here for a lot of these diseases. So how do we make it move faster? How do we learn from one disease and one program to another? How do we not reinvent the wheel every time? And what are things that can be shared that is really, it's going to raise all boats?
Dr. Wilson, I want to give you the final word based on what you've been hearing from Dr. Pariser. Where are we on these fronts?
With regards to access, the costs, although they are falling, access to the level of genetic testing that is ultimately going to be required, which is in the form of whole genome sequencing, is still not very prevalent. They're still not very accessible. In some cases, there are some organizations that are leading initiatives in certain specific disease areas that are offering services to populations and communities that wouldn't ordinarily have access to that level of genetic testing. but overall, the access is very poor. And when we look at the global population, there's only been a very small percentage of the population that's been, sequenced. And there's essentially the power to solve, human disease in general, and not only rare disease, through this technology. And so with regards to its availability, there needs to be great improvement in the availability of this testing, as well as the genetic counselors, which is also very, very critical to this whole equation, as they play a critical role in not only the interpretation of the results, but with regards to the ethics behind this testing, and for patients to have a clear understanding of what the test is telling them and what the results mean, and how that impacts them psychologically with regards to their disease condition.
To both of you, thank you, and continued good luck to the work that you are doing. Dr. Bradford Wilson, he is the co-founder and chief scientific officer for Indigenous AI, and Dr. Ann Pariser, she serves as vice president of medical and regulatory affairs at Alltrna. Thank you both for joining me today. We appreciate it.
Thank you.
Pleasure.